Moving on, state what happens to the molecules of a gas in a sealed container when the temperature of the gas is increased. Now, when the temperature of a gas is increased, specifically when the container is sealed, the molecules have a greater amount of kinetic energy. The molecules have a greater kinetic energy, which results in a greater or a higher rate of collisions between the molecules themselves and also with the walls of the container. Moving on, the quantity of gas is contained in a sealed container of fixed volume. The temperature is increased. State in terms of molecules 2 reasons why the pressure increases. Here, we know that volume is kept a constant. Volume V is kept a constant. And when volume V is kept a constant, we understand that the molecules are given more energy. And since the molecules are given more energy, they have a greater kinetic energy as explained in part A of the answer. And this greater kinetic energy results in more collisions, not only with the molecules or among the molecules themselves, but also with the walls of the container. And this thus helps increase the pressure. Moving on to the next part, a helium-filled weather balloon is held at ground level. The volume of the balloon, V1, let's assume, is 4,800 meter cube. The pressure of the helium, that is P1, is 98 kilopascal. The balloon is released and rises to a height where a new volume, V2, is 7,200 meter cube. Calculate the new pressure, assuming that temperature is a constant. We know that when temperature T remains a constant, pressure P is inversely proportional to volume, or pressure times volume is a constant, which tells us that pressure P1 at a volume V1 should be equal to pressure P2 at a volume V2. Here the value of P1 is 98 kilopascal, V1 is 4,800 meter cube, V2 is 7,200 meter cube. So we can rewrite the equation in terms of P2 as P2 equals P1 into V1 divided by V2. Through substitution, you get 98 into 10 to the power of 3 because kilo into V1, which is 4,800 divided by V2, which is 7,200. Simplifying on a calculator, we get the new value of pressure as 65 kilopascal. Suggest why it may be necessary to release helium from the balloon as it rises even higher. We have understood right here that as the balloon rises higher, the pressure can keep increasing, specifically if the volume keeps on decreasing. And thus, to prevent an increase in pressure and thereby the bursting of the helium balloon, we need to release a certain amount of helium so as to reduce the pressure. And this reduction in pressure is done so that the difference in pressure between the inside and the outside of the balloon rises, which further helps the balloon rise higher.